once it's already solved, so we better start. I just want to review what we did it last time and record it, and I'm going to put it so that you just kind of, then we can move to a new subject. And I hope you already started working on your literature part. For the next week, I'm expecting to receive all the literature that I gave you to work on. At least 6-7 papers should be paraphrased. And if you want, I can give you the sample. What do I expect from you? I'll share it with you on WhatsApp as well, so you can work out on that. Okay, now, what we do here, first we just import the data, but yeah, recording start. Import the data. Again, I'm gonna be using the many countries. And the worksheet, I'm gonna select, how many banks do I have it here? Just 4 banks. I should better go with another data set. Browse. Okay. So many countries of, again, let me double check my country because I'm just curious. Okay. Data, 27 banks, yeah? Okay, it's better than nothing. Many, let's just use many countries. Okay, what do? You just go to L drive here. Data, and just copy this. Paste it here, replace. Many countries is here, but I need to kind of select all, which it did not select. Now it's selecting everything, copy, and I'll just repaste it here as numbers. Repaste as numbers, as values, okay, it says. Okay. Now everything is repasted. Second.
Excuse me, Professor.
Copy.
We can't see your
Here.
screen.
So it should be in this format. And the worksheet, this I can delete. I can call it data. Because with this colorful data, it's not going to work and it's not recognizing it. This number of the bank, I will change to ID. Years, okay. And save as desktop, many countries, final. So other many countries I'm gonna be deleting. So this, I don't need it. This is final that I'm gonna be using. So this one, I don't need it. So have you done all? No, go to L drive.
Yes, I will. 26.
When you make Control A, but where it shows 4? In Stata? Yeah, in Stata it will show 4. It doesn't show all the data. import Excel spreadsheet, browse, final, import. So as you can see here, Aisha, you can look here. So you can just, it shows only 4. Yeah, but it's more than 4.
You just changed the number of bands to the ID, right?
Yeah, that's the only thing. And I just copied and pasted in the new worksheet because in the original worksheet, the Stata doesn't recognize it, the folder. So I changed the places and so I have to declare the data set to be panel data. XTset, ID, and year. So XTset ID. So we can see here when you declare data set to be here, so it's been declared. And what I'm gonna do now, it's basically I'm gonna run the regression analysis. But before running the regression analysis, I have to test 4 issues, 4 problems that might exist in my data sets. It's multicollinearity, it's autocorrelation, heteroscedasticity, and cross-sectional dependence. But let's review them, okay? Let's review them. Where is the multicollinearity? Where is the, okay, panel data that's here. Then open it. Now, okay, it's not the thing that I opened it. Oh, okay. Now, so starting with the multicollinearity, as we said, multicollinearity exists if independent variables are highly correlated. That's a big issue because high multicollinearity refers that the variables convey redundant information, unstable coefficient. It can be very exaggerated numbers like beta coefficients. It could be very huge or could be underestimated. So whatever the coefficient will be there, it will be biased. And the acceptable range, the variance inflationary factor should be less than 10. But the best range is less than 5. Any model. This is the first thing that you should be working with. This is the first thing that you should start before running the regression analysis. So whenever I will be giving you the home project, please make sure you run this old test before you get the regression result. Then you just move to the interpretation of that regression result. So in here, I want, for example, the following models. Regress. My dependent variable will be return on equity. Asset quality will be independent, management efficiency, liquidity, unemployment, and I can use capital adequacy and maybe government stability. So I have here 1, 2, 3, 4, 5, 6. 6 independent variables. So I run the regression. Okay, these are my regression results. All of them are highly significant, but it doesn't mean anything because I need to test for all the issues that might exist. First, I'm going to test for multicollinearity through variance inflationary factor. So I'm gonna just type a start with. With stands for variance inflationary factor. So the width I'm gonna get here, it will show me whether there is a multicollinearity of or not. If it's more than 10, then there is a multicollinearity. One way to solve it is to drop one of the variables. So I run it, and I can see here, all of them are less than 5. Perfect. Perfectly selected model. There is no multicollinearity issue. So that means we can use this model. We can run this model. So this is multicollinearity test. We don't have any. Now we can move further. Let's test for heteroscedasticity. Heteroscedasticity is the variance of the errors within the across the panels. When they are unequally spread, when they are unequally distributed, which is not really good, because if there is a heteroscedasticity, some units will have higher or lower variance, which means it will give you not reliable results, biased results that cannot be used as a prediction model. So we better have the homoscedastic issue. So as it said here, you should test by using the XT test tree, and after you run the regression, like after regression, but not only just simple regression, it should be either fixed effect or random effects. But we know that when we use the fixed or random effect, when there are different countries, when there are different banks, then we apply either fixed or random. But in here, it's regardless. You can apply any of it. But once you write the old equation, then you have to type XT test 3. And if the p-value of the result that you're going to be getting in here, it's less than 1%, 5 or 10%, then there is an autocorrelation. So let's try it. Again, I'm replacing this regress code by xtreg. And at the final, I'm typing comma FE. So these things will have fixed effect. So we get the results, and we need to just test. We just type XT test 3. And it should give us some results where we'll check whether our probability value chi-square is less than 1 or 5 or 10%. If it's less, then definitely there is autocorrelation. Sorry, heteroscedasticity. So the results I get here, it's basically 0, the probability chi-square. So that shows null hypothesis rejected. So there is heteroscedasticity. Again, if p-value is less than 1% or 5% or 10%, that shows that there is okay, that there is a heteroscedasticity. That's what we have it. Sorry? Are you sure? What does it say? It's not recognized? Then it's a very good question, I guess. So if you receive something like, let's say I put here XT test, okay, and you get something like this, unrecognized comment. If it is the case, then just type find it, type XT test 3. You have these options. Go for the first one. Just click on the first and click here to install it. So then it will give you installed option, then you can run it. So we don't have multicollinearity issue, but we have autocorrelation, heteroscedasticity. Okay. And again, heteroscedasticity, it's when there is a variance of errors in terms of distribution, which is not really good. We should have homoscedastic situation where that will help us to get more robust results. Okay, now we move to autocorrelation test, or yes, please. Yeah, we took note, we just got heteroscedasticity. Now we check autocorrelation. And then based on the results that we get from the test, we will apply a certain model that could help us to solve both heteroscedasticity and autocorrelation. For now, we make a test, diagnostic test. It's like your car is broken. You're taken to mechanist. Mechanist doesn't go and run just immediately to try to repair your car. He makes some diagnosis for all the stuff. And then he finds out all the problems, then he just solves it. Okay? Same thing with this. We got the car, it's broken, now we make a diagnosis test. If there's a problem, we put all the problems list, and then we work out those problems. Now autocorrelation, it's a issue when the error terms are highly correlated over the time within the same ID, within the same country, bank, firms, whatever, okay, within the same ID or unit. Cross-sectional dependence, it is again the error terms are highly correlated. However, at one point in time, but with the different units, with the different IDs. Is that clear, the difference? Autocorrelation over the period of time, many years, but one ID, when error terms are highly correlated, which is not really desirable. Cross-sectional dependence, correlation of the error terms within one period of time, let's say 1 year, but across panel, across different firms, different countries, ID or units. So both should be tested and checked. For autocorrelation, you run XT serial. Okay, run it. Just instead of putting regress, type XT serial. And the word serial means serial correlation. And again, I run the XT serial. I can see that I do have autocorrelation because my p-value is lower than 1%. So null hypothesis rejected. So there is autocorrelation. Is that clear? Look, heteroscedasticity, when you run the test for heteroscedasticity, you should first make a regression, either fixed effect or random effect. Then you make a test. But with autocorrelation, you don't do any regression. You directly type XT serial, you put the model and run it, and you get the result. Now we're gonna test for cross-sectional dependence. In here it says run after the XTREC. So we're gonna run XTREC. This one. The rule is the same. If the p-value less than 1 or 5 or 10%, then there is a cross-sectional dependence or autocorrelation. So this is XTREC, and we have to run using this XTCSD. Okay, C stands for cross-sectional dependence. That's XT serial here. Okay, here we can see that p-value is 0. Means that Pesserant test of cross-sectional independence shows that our value is so means you should do what? Find it, type the coding, and install it.
And cross-sectional dependency also do it after
Yeah. No, it's regardless, ID fix or random effect. Yeah. After fixed effect or random effect. Not directly. Only directly it's look, heteroscedasticity and cross-sectional dependence are run after the XTREG. But autocorrelation is direct application. You directly apply it. So we can see the p-value is less than 1 or 5 or 10%. So statistically significant means that we don't do it. Now, so there are problems. Okay, there are the problems. So we have autocorrelation, we have heteroscedasticity, and we have cross-sectional dependence. Means we cannot run a simple fixed effect or random effect. We cannot. So we should run with the additional coding that will help us to correct these issues. So that we make sure that there is no unreliable results. Are you all with me? Okay. So there are many ways to do that. You can use still fixed effects. So let me just to finalize. Here I go down for correction. Here's the correction, okay? You can, for heteroscedasticity, for autocorrelation. Look, if you use this cluster ID with a fixed effect and random effect as additional coding, it will solve the problem of cross-sectional dependence. No, it will solve problem of autocorrelation and heteroscedasticity. But if you use Driscoll-Kraay method, it will solve the problem of 3: heteroscedasticity, autocorrelation, and cross-sectional dependence. I will write down. If you use fixed effect or random effect, with additional instruments like cluster ID, okay? Then you can correct for autocorrelation and heteroscedasticity. Is that clear? So I will make it like this. Okay. So in the fixed effect and random effect, if you have, let's say there is no cross-sectional dependence, only we have autocorrelation and heteroscedasticity. Then you can just apply fixed effect and random effect with additional instruments. Like we see E cluster ID that will help you to solve out. How it works? I just copy this. Here, I go for XTREG. In here, I add this coding. But this ID means I should use this because in my way, ID is written with the capital letters. I have to use capital letters. Okay, now I corrected for autocorrelation and heteroscedasticity. Again, I additionally add this coding. So we said that we assume that it has the problem. So basically, what you do you know what does the cluster word means? In econometrics. So cluster, the word it means is kind of divided into small pieces where you can then control them, where then you can correct them. So basically you're telling to Stata, please cluster my IDs so that I can control this. So the variance and autocorrelation will be under my control by IDs. And on the other side, the interpretation of VCE stands for variance. Sorry, variance or covariance estimator. Variance and covariance estimators. Covariance means when your values are highly covariated, not under your control. And you give the common cluster the data by ID. You just make it control. Okay. So for VCE, again, let me give you the clarification of this so that you will know. Variance, covariance estimator. And it only solves the problem of autocorrelation and heteroscedasticity. However, who can tell me what we should do additional in here? Is there anything that we are missing with fixed effect?
Multicollinearity?
No. Multicollinearity, we did it. There is no multicollinearity. So how do we know we use fixed effect, not the random effect? It's just for fixed effect. What about the random effect? Yeah. So we do what? Additional. Hausman test. First, you should identify if you decided that there is no cross-sectional dependence, you show the results, and there is only heteroscedasticity and autocorrelation, then you just move either fixed effect or random effect. The second step, you should show the test of the Hausman results. Either it's a fixed and random. Okay. So it could be random, but the random, you see, it gives you more significant values. I don't know what will show the results. So we will do the Hausman later. You know how to do it. But if
Should we do like the estimate for like the
no, not now, later you will do it. But for determining in your project, for example, now I decided firmly that I'm not going to give you any exam anymore. You will get the take-home project. You will be given, let's say, 3-4 hours. I will open in the Moodle 3-4 hours. So during the 3-4 hours, you have to finish it. But before that, you have to prepare everything in advance. So you prepare it, properly manage it, and submit it. And this will be the part of your final project. Where in final project, you will combine introduction, literature review, results, methodology, results, conclusion, and references, where you will come up with the final paper. And I forgot to tell you, I will select one very good final paper, which I do basically. If I like it, I will select it. And if we are successful in publishing, we'll publish it and you get a reward for it as well. Like financial rewards. Because for each publication, I receive some remuneration. And that remuneration, I will share it with you. which I do it. Now, so, but if there are autocorrelation, heteroscedasticity, and cross-sectional dependence, then you run Driscoll or FGLS all panel corrected model. So what is the, let's start with the FGL Driscoll. This guy, this Driscoll-Kraay. So you run Driscoll-Kraay, then you run Driscoll-Kraay, feasible, generalized, least square, shortly abbreviated as FGLS, or panel corrected standard error. So these three methods, they directly solve all these three issues. Heteroscedasticity, autocorrelation, panel, and cross-sectional dependence. So this is the best three tools, but which one to use, it will be depending on the data type. How many years, how many IDs. Sometimes there is a rule like if number of the years are more than IDs, then you go for FGLS. If IDs are more than number of, let's say you have 100 IDs and you have only 20 years, then you go for panel corrected standard error or Driscoll-Kraay. So one of them. But each of it will solve the problem of autocorrelation, heteroscedasticity, and cross-sectional dependence. Okay. Again, it's not difficult to use them. Let me save it. So now we know what we have here. So I will stop here. So we have 25 minutes. So I want from you, do all the tests and give me the results on model. But different model. I mean, different variables or different data set. Let's do different variables. That's it. Which one? I will keep it for the next time. I want you to go home and digest it. This, like using the fixed effect and random effect, that solves heteroscedasticity and autocorrelation. Next time when you come, we will do these three, but make sure you are really good in diagnostic tests. That you really would like closed eyes, you can do the testing.
So now we need to explore the multicollinearity,
Yeah.
correlation, cross-sectional dependence, and we need to solve the
Problem with heteroscedasticity and autocorrelation. Because to run, I will come back. To run these three methods, you have to install them. They are not available. Yeah, you want your question?
Solve the, what is.
Heteroscedasticity and autocorrelation.
With
Yeah. With the additional instruments like VCE, like variance covariance estimator, you add it. It tells the Stata control these issues. That's it. It's very simple. The only thing you need to code it, but this coding have been created by programmers. Yes. Yes. You want to see the coding like this? I can make it even like this.
So we can take two brackets, and formal is this.
Yeah? That we did it so far.
Yes.
How many banks? Like use the same data set. All banks. Oh my gosh, it doesn't work.
We need to run thousands of tests more than five. Cheaper than yours for random.
No, just make diagnosis tests and use any of it to solve it. I need to let you solve it and upload it to the Moodle. Like make it 4 or 5, minimum 4 variables.